Hello everyone. In this session, we will cover a very interesting concept that is perceptual map. Businesses can benefit a lot by understanding how each brand in a particular product category is comparatively positioned in people's mind. So, as the name suggests, perceptual map is a map of consumer perceptions. It will also help to determine how a business or brand position itself in the market. So, the agenda here is to understand what is PCA, that is Principal Component Analysis, which we will use to create these perceptual map. To understand what is perceptual map, the relationship between perceptions and positioning, benefits of perceptual maps, how can we create perceptual map using PCA, how can we make positioning strategies using perceptual map. So this is quick summary that we will discuss in this session. Perceptual map, what is dimension reduction. We'll also see one brand rating data set and we'll understand how to do this analysis in R, how to create correlation plot, how to create heat maps, and how to devise strategies. So, a perceptual map enables the marketing analyst to determine how a product is perceived compared to the competition so that they can reposition or position them appropriately. It also helps to find the individual's ideal point or most wanted location on perceptual map. It's a graph which also helps marketer to understand the competition structure among brands, products or industries. So for the brand rating data, like the one we'll use here, performing a perceptual map can let us understand how each brand is comparatively positioned in people's mind. It is also helpful for developing a marketing strategy for differentiating from other competing brands. So these map will help in answering questions like how I am positioned vis-a-vis competition, what are my strengths and weaknesses, who all are my close competitors, am I differentiated, is there any current gap in the market, whether there is a gap where I can put my new product, or if I'm an existing product, where can I go? A place which is more differentiated where there is no competition, basically finding the gap in the market. What is my ideal point? If I want to shift myself to my ideal point or to market leader or to a brand where a brand actually exists currently, what strategy or what changes in positioning messages I need to make? So what does the perceptual map display? It displays perceptions of customers. And why is it important to understand customer perceptions? Well, it is the views of customers that matters and it influences sales. So it may happen that a company thinks of a brand in one way, whereas the customer thinks of it in other way. A company might think of their products as of high quality, but if customers view the product as low quality, it is their views which will influence sales. What is the other name of perceptual map? It's also known as market maps. And how many dimensions does a perceptual map has? It usually have 2 dimensions, but it can be multidimensional. So what are dimensions? Dimensions and what are the benefits of dimensionality reduction? Marketing datasets often have many variables, many dimensions, and it is advantageous to reduce these to smaller sets of variables to consider. If we can reduce the data to its underlying dimensions, we can more clearly identify the relationships among concepts. We'll use PCA, that is Principal Component Analysis, which is a dimension reduction technique. Many ways for reducing data complexity or reducing dimensions. These are perceptual maps or PCA, exploratory factor analysis, and multidimensional scaling. In this session, we will cover PCA, that is Principal Component Analysis, and how it can be used to create perceptual maps. So what PCA does is attempts to find uncorrelated linear dimensions that capture maximum variance in the data. So if there are 10 or 15 variables, it will try to associate, to group the variables which have high correlation and try to explain it through two dimensions, and these two dimensions are uncorrelated and called PC1, PC2. Whereas EFA also attempts to capture variance with a small number of dimensions while seeking to make that dimension, but it's interpretable in terms of the original variables, whereas in PCA we derive it using PC1 and PC2. MDS also maps similarities among observations in terms of a low dimension space such as a two-dimensional plot. However, MDS can work with metric data and with non-metric data such as categorical or ordinal data. What is PCA? So, PCA is an unsupervised learning mathematical procedure that uses an orthogonal transformation to convert a set of observations of possibly correlated variables into a set of linearly uncorrelated principal components. Like I said, it will find two components like PC1 and PC2. These two components are orthogonal, that is, linearly independent, and it tries to capture the variance in all the variables. Basically, these 10 or 15, whatever number of variables you have, can be explained through these two components. You can't explain all the variation like the variance contributed by all those 10 variables if there are 10 variables in your data, but you can capture and explain most of the variance through these two components. PCA calculates a new projection of the dataset and the new axis based on standard deviation of variables. So basically, how it does is converts multidimensional or three-dimensional data set into two dimensions, and those two dimensions are basically called PC1 and PC2. PCA creates plots based on correlation among samples, or in other words, a PCA plot converts a correlation among all of the sample into a 2D graph. So basically, this projection of the data set can be, you can understand this in simple terms like PCA converts this 3D or multi-dimensional 2D by projecting data point on principal component axis. You can think it of as, these shadows. So these people are three-dimensional, but the shadows are two-dimensional, and through these shadows, that is principal components, instead of going for 10 or 15 variables, just by these two dimensions which express maximum of the variance, these variables can be explained, and this is how PCA does dimensionality reduction. So this is an example to show you how PCA looks. So the arrow represents adjectives and the circle represents brands. We can see gentle and good for children are closer to each other. Basically, people who rated gentle high also rated high on good for children. These statements or adjectives are basically the same concept in customers' mind. Or in other words, gentle and good for children go together when customers think about this product category. PCA looks for common pattern on how customer answers the questions and reduces the large amount of data into key dimensions. Please note that one perceptual map is for one product category. So what is dimension? A dimension is underlying pattern or common variation across variables. For example, like we discussed in this example, gentle and good for children tended to receive similar responses from respondents, which means they share common variants. The shared variance is one dimension. These dimensions are the backbone of perceptual mapping because they allow us to chart the variables and brands related to the dimension and one another in a two-dimension map. So let's look at this data set. This is a dataset of consumer brand perception surveys, and this data reflects consumer rating of brands with regard to perceptual adjectives as expressed on survey items with the following form. So the question goes like this: on a scale from 1 to 10, where 1 is least and 10 is most, how adjective is brand A? So how trendy is brand A? How much of a category leader is brand B? So such ratings are collected for all the combination of adjectives and brands of interest. The data here comprise stimulated ratings of 10 brands, that is A to J, on 9 adjectives, that is performance, leader, latest, fun, and so forth. And we captured this for 100 respondents, and each of the 100 stimulated respondents has observation on each of the 10 brands. So there are total 1000 rows. So this table is the adjective and the kind of survey text that they might reflect. Perform, brand has a strong performance, leader. Basically, this is shortcut. This is just perceptual adjective we are taking here. And but while asking this question, we asked it like brand, whether brand A has strong performance on a scale of 1 to 10. How much would you rate on performance? So the first thing that you'll do while running this analysis in R using PCA is that you'll read data and explore this. So you can read this data, and head function will give you the first 6 rows and tail will give you the last 6 rows. Second step is data exploration, wherein you can run summary function and structure of this data set and see like there are 1 2 3 4 5 6 7 8 9 10 variables. These 9 variables are adjectives, and the last one is brand. So we have captured the rating on a scale of 1 to 10 from each respondent on these brands. Next is data preparation or rescaling the data. So it's a good practice to rescale raw data. This makes data more comparable across individuals and samples. And how we do that? We use it using scale function. However, the statistics behind it is that from each variable we subtract its mean and then rescale those centered values as units of standard deviation. Basically, we subtract the mean and divide by standard deviation. This is commonly called standardizing, normalizing, or z-scoring that data. We have already done this in market segmentation as well. And like I said, we have done it using the scale function. So we have done it for, like you say, you can see this is subsetting, and we are selecting all the rows, and that's why have not given anything on the left side of the comma, and have selected 1 to 9 columns, which means we have selected all the adjectives and we are scaling all these adjectives, but we have not taken the 10th column because it is brand name, it's a factor, and we need not to scale this. Next is correlation plot. So like I mentioned that principal component analysis, how it does this dimension reduction is it looks for variables which are highly correlated. So it's wise to go to run a correlation plot and to have this initial inspection of bivariate relationships, and you can see and you can read this correlation plot. Dark blue color signifies that it's a perfect correlation, that is 1, which is highest, and dark red gives you -1, that is those two variables are negatively correlated. Okay, so if you see, you can find like trendy and latest are, you know, blue, which means they have some correlation somewhere like 0.6, 0.7. Latest and trendy also has correlation, trendy, latest, and yes. So similarly, you can see that rebuy and bargain has correlation. Rebuy and value has some correlation. Bargain and value has correlation. Bargain and rebuy has correlation. So these three variables has some correlation with, you know, each other, like rebuy, bargain, and value have correlation amongst themselves. And perform, leader, and serious. Perform has correlation with leader and serious. Leader also has correlation with perform and serious the same thing. So we can see that these three variables have some correlation, and these three have some correlation, and these three have some correlation. So how many factors does a correlation plot suggest? So the initial inspection gives us 3 factors that this correlation plot suggests. So next is we can find the aggregate mean ratings by brand. So for example, on brand A, we ask hundreds of respondents to rank brand A on a scale of 1 to 10 on performance, on leadership, on latest, on fun, on seriousness, all these. And if I combine the mean value of all those 100 respondents, we can do this using aggregate function. You already know that. And we have this dot and tilde, which means that it is considering all the variables, and all the variables to be grouped by the categories of brand, because brand is the only factor or categorical variable. And so by brand we have clubbed, we have aggregated, and and we are checking the mean of these variables. So for 100 respondents, what they have rated performance on a scale of 1 to 10, we have taken the mean of those 100 respondents. And similarly, you know, for we got this table. Next is we need a matrix. We need to change certain things in this previous table that we are seeing, in order to input it in heat map that we will be making next, because it's easier to read this data through heat map. We need some transformations, and the transformation includes that we need to use brand for the row names, and we have to remove brand name column. So you can see the difference between this, where brand is, you can see brand as column, but here brand names are used as row names. So once you do this transformation, you can arrive at this heat map, and you can see that you know, the green color indicates a low value on of brand name of that variable on that brand. Okay, and the dark blue indicates a high value. So by default, heat map sorts the columns and rows in order to emphasize similarities and patterns in the data, and that which is why the rows and columns are ordered in an unexpected way. See, A is here, B is here, C is here. So instead of you know, from A B C D E F G H I J in that running order. It has ordered it based on the similarities and patterns, and it does this using a form of hierarchical clustering. We'll not go in that detail how it does, but we need to understand that how we can read this heat map. So you can see that, if we go on, F and G, they are very high. This is dark blue color, that is rebuy and value. They are seen as brands which are high on rebuy and value. They are seen as valuable brands. Whereas B and C, these two brands rate high on seriousness and leadership. um, we can see IHD, these are brands who are ranking low on performance to rebuy. All these parameters kind of ranking low, because the green color indicates a low value, and the mean is low for these brands. But these three brands have like high intensity, high color, that is high mean, and are seen as brands latest, trendy, and fun. These three brands, IHD. If you see EAJ, so they are again, E is a brand which is like ranking little high on all these variables: leader, bargain, value, rebuy, latest, trendy, fun. Not on trendy, but yeah, latest, and little on bargain, and somewhat on these parameters, that is 20. So E is basically loading on, is moderate on all these parameters, all these variables, and A is high on fun, and moderate on latest, value, and bargain. Whereas J is again high on fun, and bargain and value little bit. So that gives initial inspection, and to see, to have that understanding of the data, that which brand is loading high on which. It gives a very easy way of visualizing this. Okay, so next is we will look at the principal components analysis. And one thing is that which we can run it using this principal component function, and we have selected all the variables, that is 1:9. We have 9 adjectives, and we can call for summary of this. Okay, brand.pc is, we have given this a name, that is brand.pc, and we have assigned this a name, and we are asking for principal component of this data set, and we are not giving any rows, number of rows, because if whatever we are subsetting it by columns, that is first to 9 adjectives, and if we are not inputting anything before on left of comma, that means we are asking for all the rows, basically all the respondents, and we are asking for this principal component analysis on 9 variables. Remember, we are not taking brand, which is our 10th variable. We are taking only 9 variables, which are 9 adjectives. And you can see that this principal component analysis, this gives the variance. So first principal component is explaining 33% variance, second 23%, and third 11.9 or 12%. And if I add this, 33 is first, 33 plus 23 is 56, 33 plus 23 plus 11.1199 is 68%, and you can see that which component measures the maximum variance. So we can see that PC1 measures the maximum variance, and that's why it is the most important variable here. Remember, the X's are ranked in order of importance. So PC1 is more important than PC2. And after that, we can see this, instead of going and checking it here, there's one more method of doing it, and that is scree plot. So the default plot for a PCA is a scree plot, and which shows the successive proportion of additional variance that each component adds. So these are the number of components and how much variance they are adding up. Okay, so all the variables explain 100% of the variance, but what are those components which can explain, maximum components? We can interpret this using scree plot. And wherever, it's often interpreted like, wherever the line has an elbow or a kink, like this in that, like the angle of bending, wherever it has, and that suggests the number of components one should go for. So the elbow occurs at either component 3 or 4, depending on this interpretation, and this suggests that the first two or first three components explain most of the variation in the observed brand ratings dataset. So what we did next is we plotted, and through a pie plot, but because we collected, and these arrows are showing the adjectives, but it's a very busy chart. Reason being because we plotted it on all the individual respondents, and a better solution is to perform PCA by using aggregated ratings. So if you want, you can skip this step and directly go on, creating PCA using aggregated response, and we have scaled it again, or you can go through the same function that I discussed in previous slide, how to scale it, and you can compute this principal component. And here you can see that the first principal component explain 50% of the variance, second explain 33%. So if we combine first and seconds, first is 50% and second is 50 plus 33, total these two components explain total 84% of the variance, and which is very good, and so we can focus on interpreting results with regard to them. So once you, after calculating this PCA and principal component principal component results, and checking this importance of components, you can draw a perceptual map. It's just a biplot and of this brand.mu.pc, whatever principal component. Okay, it's a biplot of principal component, and sorry, and you can arrive at such plot. And here we can interpret this, but first let's see this code. So this is the principal component, this is the principal component, and main brand positioning is basically the title that you want to give to this chart. And CEX is just a label. We label it with a 50% larger font using the character expansion argument. This is character expansion argument, and I have mentioned it 1.5 because we are going with the 50% larger font here. And yes, so by plotting against principal components, a biplot benefits from the fact that components are uncorrelated. Remember, I mentioned something about these two components which are uncorrelated, and it makes sense. Like if they are correlated, then what's the point? Then they'll come in under. So by plotting against principal components, a biplot benefits from the fact that components and are uncorrelated. And because these two components are uncorrelated, this helps to disperse data on the chart because the x-axis and y-axis are independent. And when there are several components that account for substantial variance, it is also useful to plot components beyond the first and second. So in case in this where we are getting 84% of the explainable variance, if that would not have been the case if it, so here where we are getting 84%. And when there are several components that account for substantial variance, it is also useful to plot components beyond the first and second. So here we got like 84% of the explainable variance. Had it been low, we could have gone for PC3, and we could have plotted PC3 with PC1 and PC2 with PC3, and could have arrived at two perceptual maps. So we can interpret this perceptual map. First, we interpret the adjective clusters and relationships, and see that there are four areas with well differentiated set of adjectives and brands that are positioned in proximity. So brand F and G are high on value and bargain, while A and J are relatively high on fun, which is opposite in direction from leadership adjective, that is leader and serious. And there are arrows that show arrows show the best fit for each of the variables on the principal components, and we will see that later. And but these arrows are useful to inspect because the direction and the angle of arrows reflect the relationship of the variables. So a closer angle indicates higher positive association, while the relative direction indicates positive or negative association of the variables. So they have like, they are closely associated. These two are also serious leader BC. They are closely associated. And so you can read these perceptual map. They have like some characteristics. Like I mentioned, the arrow shows the best fit for each of the variables, and these vectors indicate both magnitude and direction. So if the arrow is longer, is long vector, then it is relatively important. And the direction of the arrow tells whether it is opposite or it's in same direction. Like we saw it here, that fun, these two brands are fun, they are seen as fun brands, whereas relatively fun brand, whereas C and B are seen as relatively serious and leader. Another thing is that attributes that are both relatively important and close to the horizontal axis can help in interpreting the meaning of the axis. Let's see how. So if we have, the question is, how would you name vertical and horizontal axis? Basically, you can, this PC1, you can just extend it and draw it here, and there's this horizontal axis, and then there's this vertical axis, and you can see the angle. So the angle of rebuy with this horizontal axis is smallest, so we can describe PC1 as rebuy. And similarly, if I see with vertical axis, it's serious, which has smallest angle with this Sirius has a smaller angle with this vertical axis. So I can rename the horizontal axis as rebuy, and I can name this vertical by seriousness, because the angle between this vertical axis and This adjectives is smallest. Next is we will discuss one case study and we'll understand the positioning strategy of brand E using this perceptual map. And suppose you are a manager of brand E, what does the map tell you? How your brand is perceived, whether the brand is differentiated, what is the ideal point, what you should do about the position of your brand E, and what messages the brand needs to emphasize. So we'll cover all that. So you can see that brand E is here and there is no adjective here. The reason can be that this brand is loading moderately on all the variables, and clearly it's not differentiated, but maybe it's loading on all the variables. But if you remember from this heat map, it says the same thing. This brand E is loading on most of the variables, so it is not and is not loading high on any of the variables. Basically this brand uh, is not a differentiated brand. So there are three things that brand E can do. First, do nothing, that is do not differentiate. So for one thing, your brand is in the center and it appears that it's not well differentiated on any of the dimensions. So that could be a good thing or a bad thing depending on your strategic goals. If your goal is to be safe brand and appeals to many consumers, then it is a relatively undifferentiated position like E could be desirable. On the other hand, if you wish your brand to have a strong differentiated perception, this finding would be unwanted. What should you do about the position of your brand E? Again, it depends on the strategic goals. Second thing that brand E can do is that increase differentiation. One possibility would be to take action to shift your brand in some direction on the map. Suppose you want to move in the direction of brand C, you could look at the specific differences from C in the data. You can calculate this by taking brand mean of C and subtracting brand mean E from it. And let's see, the output looks like this. So this output suggests that the positive value, that is brand C minus brand E, positive values indicates that C is high on performance, C is high on seriousness, and although C is high on leader also. And whereas E is high on latest, E is high on fun and bargain, value and rebuy. But E is highest on bargain and after that fun. So basically if E wants to shift to the position that is currently occupied by C and wants to position itself as as a market leader or the brand that is currently occupied by brand C, then E needs to strengthen on some messages, that is like performance and leadership and seriousness. So E needs to position itself as a brand which is high on performance, which is a leadership brand, which is a serious brand, and drill down all the messages which are currently talking about fun, latest, or bargain, or value, or rebuy. Okay, so E is relatively stronger than C on latest, fun, bargain, and rebuy. And highest on E is currently highest on fun. So basically E is currently seen more of a fun brand in comparison to C. And in order to position it as C, It needs to be relatively stronger on all those messages where C is currently high. So E needs to increase or strengthen messages on performance, leadership, and seriousness. This is what E should do, and should drill down, uh, dial down messages on latest, fun, bargain, all the others. So next, the third thing what E can do is not to follow another brand but aim for differentiated space where no brand is positioned. So we can see that there is some gap between this area, which is kind of a value leader area, and E can position itself to this area and move itself to this area, which is a differentiated space. And how E can do that, although there's some risk involved in it, but we can assume that the gap reflects approximately the average of these four brands. And we can find that average using column means, and you can put all these adjectives and subtract brand mean E from this, and you will see that brand E is basically needs to focus on performance and needs to focus on rebuy. Performance and rebuy are two most important things where brand E needs to focus. If I ask about the third thing could be serious. So these three things are the most important messages that brand E needs to strengthen. And whereas brand E needs to dial down the messages on latest and should not show itself as a fun brand or should not show itself as bargain. So these are the things that E can do in order to position itself to this value leader area brand. So the summary is that when you wish to compare several brands across many dimensions, it can be helpful to focus on just the first two or three principal components that explain variation in the data. You can select how many components to focus on using a scree plot, which shows how much variation in the data is explained by each principal component. A perceptual map plots the brands on the first two principal components, revealing how the observations relate to the underlying dimensions. PCA may be performed using survey ratings of the brands or with objective data such as price and physical measurements, or with a combination of two. In any case, when you are confronted with multi-dimensional data on brands or products, PCA visualization is a useful tool for understanding differences in the market. It can be used for product ratings, position of consumer segments, ratings of political candidates, evaluation of advertisement, or any other area where you have metric data on multiple dimensions that is aggregated for a modest number of discrete entities of interest. There are some cautions with perceptual maps. You choose level and type of aggregation carefully, like we aggregated it based on me. Second thing is the relationships are strictly relative to product category and the brands and adjectives that are tested. So it's very relative. Third is the strength of a brand on a single adjective cannot be read directly from the chart. And so we say it that compared to its position on other attributes, brand X is relatively differentiated by perception of strength or by perception of weakness on such and such attribute. So we use the term relatively differentiated. Next, despite these caveats, and perceptual maps can be a valuable tool. We use them primarily to form hypotheses and to provide material to inform strategic analysis of brand and product positioning. If they are used in that way rather than as absolute assessments of position, they can contribute to engaging discussions about positioning and potential strategy. Thank you.